This video is about quadratic inequalities in one variable. As you can see here on the left, we have a quadratic, except that instead of this time it being equal to 0, we're looking for the values of x that are greater than 0. If this were being graphed as a parabola, this would open downwards. The negative sign in front of the x squared will make this parabola open downwards. So what we're looking for really are the x values that when we plug them in, will give us answers that are greater than 0. In other words, we're looking for the x values that will return answers above the x-axis. It will give us positive y values. Now, the first step in this process is to find out the x-intercepts of that quadratic. We want to know the zeros. We want to know what values of x that if we plug them in would give us 0. So luckily this one is factorable, so we can divide by -1, factor into two binomials, solve, and we get x equals 6 and x equals -3. The next step is to construct a number line and put in the two x-intercepts like this. And you'll notice that I've put in this dotted line. That's an indication of where the parabola would go if this were being graphed. It would open downwards, and therefore the region between the two x-intercepts would be above the x-axis. That's actually the solution right here. This is where the quadratic will return positive values when we plug in any value of x that is between -3 and 6. Now, if we plugged in x values that were less than -3, it would return negative solutions. If we plugged in x values that were greater than 6, it would return negative solutions again. So the correct numbers to plug in to get positive answers out, answers greater than 0, are the ones between -3 and 6. You'll notice that I've kept the circles open here because the inequality doesn't have that little equal sign underneath. So that's why I have the -3 and the 6 excluded from the domain. The only thing left to do now is to write the answer down in domain notation. And here's how it would go. It's all the x values such that all the x's are greater than -3, they are less than 6, but they don't include the -3 and they don't include the 6. And just say that the x's are all real numbers, and you're done. That's your solution.